Welcome everyone. I would like us to look at determinant, adjoint, and inverse of a 2x2 matrix. These three elements will especially help you when you want to calculate or when you want to get the solution of a pair of simultaneous equations using matrices. Let's start with the determinant. Now, given a matrix, M, N, O, P, the determinant is given by you take M here times P, take M times P, and then subtract N times O. So M and P, these are elements that lie on the leading diagonal, and NO, these are the elements now of the other diagonal. So take the difference between the two, and that will give you the determinant. Now adjoint now becomes you take the matrix MNOP, flip the elements of the leading diagonal, that is MP. So when you flip them, you interchange them. What do I mean? This is what I mean. You take P, P goes there and M comes here. So we shall have here P and M down here. Now, the values of the other elements, that is N and O, you flip their signs. Like for example, in this case here, N is positive. When you flip the sign, it becomes negative N. And here also O is positive. When you flip the sign, it becomes negative O. So this is the adjoint of matrix M here. So MNOP, we can call it matrix A. Yeah. So the adjoint, so A adjoint becomes now P, negative N, negative O, and M. That is the adjoint. Now, when it comes to inverse, now inverse of A, denoted by A power negative 1, becomes now you take the determinant, you take the adjoint divided by the determinant, take the adjoint divided by the determinant. So that will be what you take now. The adjoint is our P, negative N, negative O, M. That matrix divided by the determinant, which was MP, because M times P is MP minus NO. Yeah, so this is how you calculate the determinant, the adjoint, and the inverse. So this is how you do it. Now, if I may take an example that given matrix A equals 1, 1, 2, 3. Given matrix A is 1, 1, 2, 3. No, this one here is negative 1. So 1, negative 1, 2, 3. Determine its inverse, or okay, determine A inverse. Determine A inverse. Now we know that A inverse is the adjoint divided by the determinant. Yeah. Now what is the adjoint here? So adjoint, so the solution will be now, you start with the adjoint, which becomes now, you flip now you interchange the leading diagonal elements. So 3 comes here and 1 goes, and then you flip the signs of the other elements. So here it was -1, it becomes +1, and here was 2, it becomes -2. Yeah, so that is what we have. Now, how about the determinant? The determinant becomes, take 1 times 3 here, minus -1 times 2, just like we did in the previous example. And this one is the same as 3 minus -2, which is 5. So the determinant is 5. Hence, the inverse becomes 3, 1, -2, which is the adjoint 1, and then divide by 5. Or you can write and say this is 1/5 times 3, 1, -2, 1. Yeah, so this is how you get the adjoint, the determinant, and the inverse over 2 by 2 matrix, which is useful when you are calculating you are solving a pair of simultaneous equations. Now, in my next video, I'm going to show you how to solve a simultaneous equation using the adjoint, the inverse, the determinant, just like we have done here. If you like this video, please like and share with friends. Otherwise, until my next video, bye for now.